historical trends from your history. Oh, we're getting a little issue. And the idea is, instead of looking at just the history, you want to, and past trends is there's, you want to also look forward for using predictive analytics on this data on there. So this is where machine learning and AI comes into place. And the idea is you want to build a solution and a data architecture that we'll talk about today that could handle data no matter what the size or the speed of the type of the data. So this is when we talk about a digital transformation. And the data architectures I go today are this stage 2, where you need to collect all this data together. And there's lots of different ways of doing that. And so I'll hit on what I would say are the 4 major ones. The first thing that I usually share when talking about a data architecture, any one of these, is the need for a data lake. And there are lots of reasons. I've added to the slide over the years, and I'll have a few of you I'll point out. And this deck will be available for you to dive deeper into some of these reasons that I list here. But you can think of a data lake as a staging area if you have a relational database or a data warehouse, where normally with this relational database, you kick people off because you have a maintenance window and you load data in there, and then you clean the data and you hope that it finishes in the maintenance window, and then you have people pop back on there. Well, with a data lake, what you can do is you can land all that data in the data lake instead and clean it in the data lake. And then once all that is finished, you can then copy it to the relational database, so that maintenance window becomes just a few minutes where you're loading the data. And therefore, you can have a data warehouse that's essentially 24/7. And in the data lake, you can also save costs because the compute could be a lot cheaper than doing it in some relational database solution. And also, you can have as much compute as you need when you're in a data lake. Because data lake is just a glorified file folder in there. So you can dump data in there. You can do schema on read, means that I just copy files in there. And I can then put compute on top of that. And I can, if I want to spend more money, I can have massive amounts of compute that could clean and transform and do all these things to that data, so it's ready for that data warehouse in there. The data lake is also great because it allows that power user, that data scientist, to quickly look at the data and see if it's got value, and then maybe run reports or queries on top of that for a one-time use or build machine learning models. As opposed to, and this happened when I was a DBA, is some end user would say, hey, I have this data that's out there, and I'd like for you to put it in a data warehouse because I think it's going to be really useful. And so you go and you create a database and a table and the fields, and you write the ETL and you copy it over there, and you give it to them, and then they go, oh, actually, this is not useful, and I wasted all this time and effort. And that's because a relational database is schema on write, so you have to do that work up front. With their data lake, you just dump the file in there, and especially with some of the technologies today, you can quickly and easily read that data, use it, or investigate it, and if find out it's useful, then you may want to move it to a relational database, but you don't have to do a lot of upfront work. And then the other thing I'll say is, and I touched on this a little bit, is the user contention that happens if you have a process that's loading data or doing any kind of transformation to that data, and you decide to open it up and allow people to query, is now you're not only can get inconsistent results in there, but you can have this contention where everybody's fighting for this compute. And if you're doing things like trying to create a long-running report on there, and at the same time you're trying to load data in there, you can have all this contention in there, and you get a lot of angry end users on there. So those are just a few of the reasons for a data lake, and I've seen almost every situation customers are creating a data lake along with the data warehouse. So if you look at how you split those two out, is the data lake, it could be thought of as a staging and prep area, and then the data warehouse could be that serving and security and compliance. Because Without one or the other of these, you can have trade-offs on that. Without a data warehouse on there, you could have problems with performance and security and concurrency. And without a data lake, you can have problems, as I mentioned before, as well as issues with having a very high cost by just having a data warehouse because the compute on that is very expensive. So in most situations, you have both, but there are some exceptions that I'll talk about in a minute. But if you want to look at the differences between the two, you can look at it at this level. Now, when we get to a modern data warehouse, this is where I usually a whiteboard. So in the fact that I only have 30 minutes, I just show you what the end result is. I always break out the modern data warehouse into 5 steps, and this is usually 5 stages. This is usually what everybody breaks it out to. They may call it something a little different, but they come out to ingest. So I need to take this data from the sources and pull it in to stage number 2. That's where I store it into a data lake, and that data lake can have many different layers. A raw, clean presentation. It could be a sandbox layer. Each of those layers can have various folders within them, and I can spend a whole day with people, customers, just explaining the way you do data lake design on here. And you need to spend some time up front to think through it, so you're not having to go and redoing what you did because you didn't put enough thought into creating this blueprint for the data lake. Step 3 is to transform that data. So once it lands in there, it's just storage. I then can do that cleaning of that, and maybe I first convert everything from CSV files, JSON files into Parquet, and have a conform layer, and I add that into there too. And then I clean them all, and I join the data in there and make it ready for presentation layer. So that's step 3. And then 4 is to model it, where, as I said, you usually want to have a relational database on there. Now you have to take these flat files and model them into a third normal form in a relational database. You may also then copy that data into a star schema. So you're doing additional work, and it's more costly, but in the end, you're putting the data in a format that makes it very easy for an end user to query that data and do self-service BI. It could be very easy for them to go to some tool like Power BI and just click and drag fields onto it without having to know how to join them all that. And it's all done for them behind the scenes, by the upfront work, so they can create their reports without getting IT involved. For those 5 different steps, I listed out here what you would use if you were in the Azure Synapse, Microsoft Azure world cloud here. You use Azure Data Factory, Data Lake Store Gen 2 for storage, Data Factory to data flows, or Databricks, or even Synapse Serverless now for that compute. And then Synapse could have a dedicated pool to store it, and then Power BI as the visualization. And you could plot this out and put in Amazon, AWS, or Google, or Informatica. It all can fit in here. It's using any tool. The difficulty is what you got to think through is the design of this architecture. And then there are some nuances with the tools and some things you can do to be more cost effective, and that's why it could be a long discussion on an architecture. And with most customers, I spend time asking them a lot of questions so I can narrow the tools down and find out what their price point is, what their skill set is, and then give them the best tools for what in the toolbox for what they're looking at doing. Okay, so modern data warehouse here. It's almost always cloud-based. I would say it's not. If it's not cloud-based, I wouldn't call it modern. And what I say a data fabric is kind of building on this modern data warehouse. So taking all these things I've talked about and adding other features onto it, getting into data access and data policies. Maybe you need to put ABAC, attribute-based access control, on there. Having some metadata catalog, and like in the Microsoft world, it would be Purview that tracks the lineage, adding master data management, virtualization on there, data scientist tools, making it APIs to access all the data is building an API layer for it. And it may be that you create these building blocks within it. So I have an ingestion piece that is a building block that I break the teams out by, but I can also have other organizations who don't want to use this data fabric I'm creating, but they really like my ingestion piece, that they can use that and as a service on here. And this is how we're doing things at EY when we're building a data fabric, is in these building blocks for those that are not able to use the data fabric as it sits. Now, this is where it's my definition might not fit others. I've seen other people that consider the modern data warehouse and the data fabric the same thing. I've seen people talk about data fabric and data mesh being the same thing. So I'm just coming out with mine, and I think it makes sense. And there's a little bit of complexity that comes if you add virtualization to it. Does that make it a data mesh and stuff? Those are arguments for another day. But be aware that my definition may be different than what others think. All right, the other thing that is fairly new is the data lakehouse on there. And if we look at the history, when we started with the data warehouse, and then it was just relational databases, I was well into my career and doing a lot of database design and development. And then this thing a data lake came out only about maybe 15 years ago, if even that much, Cloudera and them about 10, 11 years ago. And the idea was, oh, I can use data lake for everything. And it's this magical land of unicorns and rainbows that I can put all the data in and get it out. And I saw a lot of implementations fail because they thought they can get away without using a relational database. And what then changed was customers said, well, we need both. And I talked about those reasons to have both. And so you have this data lake and this data warehouse on there. And now what's being spurred on in large part by Databricks is this data lakehouse. You're combining a data lake and a data warehouse and calling it a data lakehouse. And the idea of this is you get rid of the relational database, but you still get a lot of the features of a relational database by using what is called Delta Lake. And this is a layer on top of the data lake that gives you these additional features like ACID compliance, part of a relational database. Time travelers, you can version things, so you can roll back and you can have an audit trail. You can unify, you can do both stream and batch with the Delta Lake, and there's performance improvements, and there's a list of a handful of things on here. But this is what allows customers that I'm starting to see to say, okay, maybe I can get away without using a relational database because I can put these features on there. And the Lakehouse tries to help with these four main issues. It's the reliability that you have when you have to have a data lake and a relational database to keep them together, consistent. Copying one from the other is a challenge on there. It's another problem with having a data warehouse, a relational data warehouse, is that the data in the warehouse may be older because it's not only the challenge to keep them up to date, which there's a time delay in there, but also there could be problems where something goes wrong and they're not all of a sudden consistent in the same view of the data. The relational database usually doesn't have a lot of features for advanced analytics. If you want to do machine learning and such on top of data in a relational database, that could be a lot more challenging than doing it on top of a data lake, because a lot of those data science type tools on there work really well with a data lake, but may not work well with a relational database. And then, of course, there's having both is extra cost, 2 copies of data on there. So this is some of the things the data lake house is trying to prevent by having just a data lake and the Delta Lake on top of that. However, there are concerns if you skip a database, a relational database on there. One is the speed. A relational database is always going to be faster than, or almost always going to be faster than a data lake in there, especially when you get into the MPP, multiple parallel processing technology in there. You'll get queries that are going to run in milliseconds as opposed to seconds, or dozens of seconds or minutes and transfer to seconds. And then that just depends on what your SLA is, how fast you these queries need to run. You also may miss out on certain security because in the data lake, there is no row level security. It's all file and folder based on there. You don't have column level security. You don't have dynamic data masking. There are workarounds for this or other products you can buy, but now you're adding extra cost and complexity to get some of these features in there that are part of a relational database. And another one is complexity in there. If you're dealing with a file and folder format in there, there's just, the more data sources in there, the more folders and files you got to create, and it could be just a really big mess because the metadata is separated from the data. And so it could be very challenging to find things in there, especially if the metadata is not matched up correctly on there. So this file-based world could be a much difficult thing to transverse compared to putting things in a relational database where the work is done and it's a lot easier to find things in there. And then finally, there's some missing features that you don't get in a data lake, like referential integrity that I list here. And I added to this slide recently to say with Azure Synapse, this product that's fairly new from Microsoft, I'm starting to see data lake only solutions. And for two main reasons. One is you can use T-SQL, where a challenge with using a data lake is in most products, you have to use Spark SQL or Hive SQL. And if you're used to T-SQL, that doesn't fly. You need to have T-SQL in there. And so Synapse allows you to use T-SQL over data and sitting in a data lake. So it actually appears that it is a relational database when actually it's data over the data in the data lake in there. And then if you add Power BI to it, you can get additional speed. You can get that millisecond response time, and you can get roll-up security in Power BI. So if you are using Power BI and Synapse, you can certainly have a use case that I can get away with only a data lake and not need a relational database. All right, data mesh, the talk of the town lately on here. The way I like to think of a data mesh is all the solutions I talked about before were centralizing the data. It was copying it from source systems, from various domains in an org into one central location. That central location is a data lake, is a data warehouse, or it's both, or it's either or in there, but it's all centralizing. The data mesh concept is much different in keeping data decentralized. And it's a big shift, a mindset shift in there, in that you have to think, and I should mention this, data mesh is an organizational change. It's not a technology solution on there, which is one of the challenges of it. It sounds great in theory, but there are some concerns when you try to implement this. But in the theory part of it, which sounds great, is that you now have ownership by all the domains. So instead of copying everything into IT and having them own it, it's kept within the domains. And you don't have as much ETL because you're not having to centralize everything. So ETL is just within each of the domains in there. And then you can start thinking of data as a product. So each of those domains is usually given a contract where it says you will abide by this contract and you'll make this data available to everybody else. And now that data is used like a product. So anybody who wants to use data in various domains can easily get to it because they're all abiding by this one contract, and the way to access it is all the same. You can also then have data engineering teams that are sitting within each of the domains instead of having everything within IT. So that helps reduce the bottleneck in there. And it's that data as a product, and that can make it scale, because now you have each domain with its own various teams and its own various data lakes and data warehouses. And so if you need to add a lot more data, a lot more domains in there, it could be a lot easier to scale that way than trying to centralize it all. And this was, Zamek was the one who kind of coined this term data mesh, although a lot of these concepts, and you'll hear a lot of arguments over this, have been around for quite a long time. It's just trying to combine them into a nice term and make it, evangelize it more so people are aware of this, of what this can do. And so the data mesh tries to solve 4 areas: that lack of ownership. So now it's just the IT team. It's not just not the IT team, but it's out of the domains that own the data, and who knows it better. So they own it and then they clean it, and so it's going to be cleaned better in theory because they know the data better than the IT team does. It allows you to scale, as I mentioned, and the other thing it solves is a challenge of technical scaling, where a lot of the current big data solutions are not able to keep up with this additional data in there. And with this approach, because it's all federated and spread out, you can overcome those problems that big data solutions are having with not keeping up and not being able to say, sure, I can add this other data. A lot of times they may say, well, I can't because I have no more scaling I can do. All right, so all that being said, there's a lot of arguments I can make against these four supposed challenges on there. And I've blogged about this, and I'll just point out one, like the technical scaling, which I strongly disagree with. I've been involved with MPP technologies for about 10 years, starting out with the parallel data warehouse at Microsoft, and it works and it scales. And the technology is not stood still. It's gone to a point where it can handle many petabytes of data. And there's many examples of that, Microsoft being one, where they have their own internal data lake and data warehouse in there that's handling petabytes of data. So you have to take with a grain of salt that that some of these things are not keeping up, because in a lot of cases they are. And so some of the concerns I have with data mesh, I just talked about them, but there's a lot, and I've talked about more of these in the blog, and I didn't even put all of them in there. Just pointing out a few, and I think the one that I have is there's no standard definition of data mesh. If you talk to 10 people about what a data mesh is, you probably get 15 different answers on there. So how are people going to go and implement data meshes if nobody can agree what they actually are? And I think the biggest, by far, challenge is it requires this organizational change. It says you're going to go out to the domains, and domains are now going to handle the cleaning of the data and the mastering of the data. And they're going to have to abide by this contract to how they're going to make that data available. Boy, that's a tough thing to do, and especially in large organizations. You have to go to all the domains and say, you're going to change the way you do things. It's going to be your responsibility, and you're going to have to come up with some kind of incentive for them to do that, because now it's more work for them. And you can argue that they're going to come back and say, look, I'm just worried about my domain. If you want to combine it with other domains, fine, take a copy of it, but I'm not concerned about other ones in there. And so that's going to be a challenge, and they may say, we're not going to abide by the contract. So just a lot of things to think through, and just be aware of these. So I'm not saying a data mesh can't work, but you have to think through all these concerns and make sure your particular company can get past a lot of these concerns. Otherwise, you're going to take a couple of years to build a data mesh, because this is another thing, is there's no quick solution. This is going to take longer to do than it would a traditional data warehouse. So you have to be aware of that, and you don't want to be 2 years down the road and realize data mesh is not working for you. And so some of the keys for a successful data mesh are, you got to have current pain points on there. So if you're going and saying everything's working great, don't just go, oh, it's this great buzzword, I'm going to go and use it and change everything in there, and you're not really solving any of your pain points that you may not have any pain points that you really need solving. You definitely need to have a company culture that's open to change, which, as we all know, that can be a huge challenge, and especially when it's this vast change that a data mesh has in there. So you have to really have a temperature of your company where they're going to be resistant. If you go around and banging the drum saying we're going to data mesh, you may get pushback. And all it takes is one domain to say, I'm not doing that domain data mesh. And now they're isolated. They're out of the data mesh. And now what do you do on there? And if you say, well, I'll just have to include that data mesh and pull it in my own, now you're going back to making it somewhat of a data mesh. There's exceptions. And that's the problem I see a lot with companies. If they get away from the traditional data mesh, there are always these exceptions. And in Microsoft's world, one of their exceptions is you want to centralize the data. You don't want to have everybody with different data lakes. And so in their view of it, which is my assumption from hearing from people, is you're trying to create one data lake and just separate it by folders out there. So it's not centralized, it's centralizing of the data. You want to have experienced people, if you can find them who've done this before, or who at least really understand those concerns in the data architectures. And this is another issue I have with data mesh, is they go, well, 70% of the data warehouses fail, and the data mesh is going to solve that. And I say, no, I think a data mesh is going to make it more fail, because it's a lot more challenging to put a data mesh, to build a data mesh in there. And it's not usually the technology or even these high-level concepts. It's the people and processes you put in place. Those have to be there no matter what data architectures you do, or else you're going to have a failure. Be aware of those concerns I mentioned. Don't just jump on it because it's the latest buzzword. And here's another big one. Don't listen to vendors. I'm seeing a lot of companies that say, hey, we'll solve your data mesh. And some of them even go to the point where it's practically, we have data mesh in the box on that. And they're trying, a lot of the virtualizations companies are trying to say, well, we we solve the data mesh in there. But again, the data mesh is one big thing, and you could even build a data mesh without using virtualizations in theory on there. But it turns out you need that technology, which then provides its own challenges for performance. Because if I have all this data in all these different domains, you want to join all that data together, and all the data is sitting out who knows where in these domains. Well, I'm not going to put them all together in there, and usually you use virtualization software. Or the data mesh also says you can pull that data together and have a domain that's aggregated, which kind of goes away from I would say the main purpose of data mesh was not to do that, not to have copies of the data. Now you're having to do it, but for performance reasons. So then who owns that? And now you're getting all the problems that you're trying to solve. And finally have a very long runway, because if you look at the companies out there that have built or are building data meshes, it's taken them many months, in some cases years, to build it. So you have to think this is a long-term solution that you're building. And then finally, the difference between data fabric and data mesh I outlined here. And one I'll point out is the governance on here. If you're now saying to the domains, you go and govern the data, you don't want them all doing it their own way. You don't want somebody who decides, I'm going to have US states abbreviations and somebody else using the full name in there. So you have to provide a unified governance layer on there. As a data mesh, you have to kind of push that out and hope that people adopt it. But in the end, it's a multiple governance layers in there, because they're going to do it the way they want. So a data fabric, so it's extra work to centralize it all, but you have one governance layer on there. So you can look at this slide as it could be pro data fabric compared to data mesh with some of these things on here. But in the end, I just try to educate everybody to be aware of all these differences, and then pick the one out that works best for you. And then maybe a combination. Maybe in your organization, you do data mesh for certain things and a data fabric for others. And that's what I find most customers are guided through that way of solving, is not put everything in one data mesh, but make that a special case in their organization. All right, so hopefully that was understandable, a high-level overview of all these different terminologies on there. Happy to have you email me if you need further clarification or just discussions about these. And feel free to visit my blog, where I go into more detail about those topics that I brush over very quickly. And in this deck, I have a number of additional slides that are at the bottom of it in an appendix. So feel free to look at those and hopefully get a better understanding of everything I talked about. So thank everyone for joining, and I hope to join you again on when the next buzzword comes out. So thanks.